All right, so today we're going to look at the third method that we'll use for solving linear systems, and that method is called linear combinations. So what we're going to do today is walk you through that over the next couple of days, actually. So we've done graphing, where we graphed the two lines and found that point of intersection, and then we also did substitution, where we would solve for one of the variables, plug that number back in to solve for the other. To plug that expression back in, solve, and then we would plug that number back in to solve for the other variable. So our last method now is this linear combination, and that's our goal for today, is to solve systems of linear equations using the linear combination method. So please make sure as you watch this video that you are taking notes. You can pause it, rewind it, and everything, whatever you need to do to make sure you get a full understanding of it. All right, so first of all, let's talk about the process. So it's a four-step process when you use the linear combination method. First of all, you're going to multiply one or both of the equations by a constant if necessary. That's very important. You won't always have to do that, so I'm going to put a box around this. So only if that's necessary do you need to multiply. And you'll do that to obtain coefficients that differ only in sign for one of its variables. And remember, the coefficient, that's that number attached to the variable. If when you look at the equation you have opposite signs, opposite coefficients, there's no need to multiply, so you would just go ahead and move on to step 2. And step 2 is to add the equations from step 1. You'll combine your like terms, which will eliminate one of the variables, and then you'll solve for that remaining variable. So when we're looking at these these systems of linear equations, there's always two variables, and so we're always trying to get rid of one. And this process here in step 1 and step 2 gets us down to an equation with just one variable that we can solve for. Now step 3 is similar to what we were doing with the substitution method. We're going to substitute that value back into the equation in step 2, and then solve for it, and that'll give you the other variable. So that step 2, between step 2 and step 3, you'll solve for your x and y. You may solve for x in step 2 and then y in step 3, or vice versa. And then the last thing, as always, you want to go through and check to make sure that that point of intersection works for both of the original equations. All right, so let's take a look at a couple. So in this first example, we've got the opposite of x plus y equals 1, and we've got x plus y equals 1. So if you notice with the x terms here, this is like a negative 1x, and this is a positive 1x if we think about the coefficient. So if we were to add those, they would cancel one another out. So in this case, we don't have to do step 1. We don't have to multiply by a constant. So if we go through now and we add these two equations, we would have negative 1x plus 1x is just 0x. So these cancel one another out. And then we'll do the same thing with the y's. We'll add them. We've got 1y plus 1y, so we're going to have 2y equals 1 plus 1 is 2. Now here's what I tell you. Here's where a common mistake occurs, is over on the right side of the equation. You got to make sure that you add the constants. A lot of times students will eliminate whichever variable eliminates. They add the other variables, but then they forget to add the constants. So you got to add each of the terms with one another. So the opposite of x plus x is 0x, so that cancels out. 1y plus 1y is 2y, and then 1 plus 1 is 2. So now we've got an equation in just one variable, so we can solve. So like always, we got 2y equals 2. We'll divide both sides by 2. The 2's cancel, so we're left with y equals 1. So there's the first half of our ordered pair. Y is 1, so our y coordinate is going to be 1. And so now what we'll do is we'll take this 1, and you can come back to either equation you want up top. I'm going to take it to this one, just because my x isn't negative, or it's not the opposite of x, and I'm going to substitute 1 back in for y. So now what I'm looking at is x is my unknown, plus I just solved, and I know that y is 1. So we got x plus 1 equals 1, and now we solve. So to solve for x here, subtract 1 from both sides. The 1 and negative 1 cancel each other out. 1 minus 1 is 0. So our x coordinate is going to be 0. So our solution, or our point of intersection, is going to be 0, 1. All right, so the last thing we got to do is actually, let's go ahead and check this solution. So if we put 0, 1 back into both equations, so up here we would have the opposite of 0, which is just 0, plus 1 equals 1. So we got 1 equals 1. That's a true statement, so it works in the first equation. And then we do the same thing in the second equation. This is our first equation here. So in the second equation, if we do the same thing, we would have 0 plus 1 equals 1, or 1 equals 1, and again it checks. So we know by checking our order pair 0, 1, since it works in both equations, that this is in fact the correct solution. All right, let's move on. So for this one, again, if you notice now, the x's coefficient here is 1, coefficient here is 3. So that one right now doesn't eliminate itself. But if you look at the y terms, you've got a negative 2y and a positive 2y. So when we add those are going to cancel out. So again, this is another example where we don't have to do the first step. So since we know that our y's in this case are going to cancel, negative 2y plus 2y is 0y, so those cancel out, we can add our other terms. So we've got 1x plus 3x, which is 4x, equals, and again, remember, we got to add our constants over here. So we have negative 2 plus 10, which is a positive 8. So now in this case, in our first example, we were left with y to solve for. Now we have x. So if we go ahead and solve for x by dividing both sides by 4, your 4's will cancel here. So x equals 2. So there's the first part of our ordered pair. The x coordinate is 2. So now we're going to take that 2, and again, you can pick either equation up top that you want and plug it back in. Since this is just x by itself, I'm going to plug it in there. And so what I would have is 2 minus 2y equals negative 2. So again, we're down to just one variable. We've got a linear equation with one variable, so we can solve. So if we're solving here, we got to get rid of this 2 first. So subtract 2 from both sides. 2 minus 2 cancels out. Now be careful here because you've got this minus sign, so you got to be sure you bring it down, leaving us with negative 2y equals negative 4. And then solve for y by dividing both sides by negative 2. So you're left with your y coordinate equal a negative divided by a negative, which is a positive 2. So your ordered pair for this example, or your solution, your point of intersection, is going to be 2, 2. You can go ahead and pause it and go through and check it if you want. I'm not going to write the check out, but what you have is if you throw 2 in for x, you would have 2 minus, put 2 in for y, 2 times 2, which is 4, so 2 minus 4, which is negative 2, so it checks there. If you put 2 in for x here and 2 for y, you would have 3 times 2, which is 6, 2 times 2, which is 4, 6 plus 4 is in fact 10, so it does check in that one also. All right, go ahead and try this third example on your own. So pause the recording, go ahead and pause it, and try to work this one through on your own and see if you can come up with the correct answer. All right, so let's see what you got here. So if we look at this, looks like our x's will fall out here. We've got a 7x and a negative 7x, so those will cancel one another out, leaving us with 3y plus 2y. So we're going to have 5y equals negative 12 plus negative 8, which is a negative 20. Divide both sides by 5, so y is negative 4. So you should have gotten negative 4 as your y coordinate. And then again, you can pick whichever equation you want and substitute that y back in. I'll substitute it in there. So I'm going to have 7x plus 3 times negative 4 equals negative 12. So we've got 7x plus a negative 12, or 7x minus 12 equals negative 12. So 2 there. Add 12 to both sides, here and here. The 12s will cancel, so you're left with 7x equals negative 12 plus 12 is 0. Divide both sides by 7. 0 divided by any number is just 0. So your solution, or your point of intersection for these two lines, would be 0, negative 4. All right, don't get confused here. If you're left with x equaling 0 or 0 over 7, that's perfectly fine to have an x or a y coordinate of 0. So for this one, it should have been 0, negative 4. All right, go ahead and pause this one also and try this one on your own. All right, so let's see what we get here. Looks again like our x's are going to cancel out, so we've got 2x plus negative 2x, so our x's will go away. And then 1y plus 5y gives us 6y equals negative 2 plus negative 16 would be a negative 18. Divide both sides by 6. Your y's will cancel, so y equals negative 3. So your y coordinate again or I guess is what we solved for first, not necessarily again. So the y-coordinate is -3. So now you can pick where you want to put it. I'll go up here to the first equation, and I'm going to substitute it in here. Now you got to be careful with this plus sign and this negative sign. Make sure you don't confuse them. So when I substitute in, it's going to be 2x plus, I'll put this in parentheses just to separate the two, -3 equals -2. All right, adding a negative is the same as subtracting a positive. So this is the same as 2x minus 3 equals -2. So to solve this equation, let's go ahead and add 3 to both sides, leaving us with 2x equals a +1, and then divide both sides by 2. The 2's will cancel on the left side of the equation, and you're left with x equals 1/2. So your x coordinate is going to be 1/2, and your y coordinate is -3. All right, so that's all for that lesson. So I will see you in the morning.